Carl Summer, president of Reliable EDM, has a wealth of machining experience. Having worked as a machinist, tool and die maker, foreman, tool designer, and operations manager, Carl now shares with you from his wealth of experience.
This is a CNC small hole EDM machine. Right now, this is at 70 degrees, and we can put it at different angles. Usually we do it in a vertical position. And right now we're EDMing a small hole from this corner right into this cavity. And since it's CNC, we can go and program it and put holes wherever we program it, in different places, and we'll do it automatically. And as you can see, there is the hole into right in this corner. That's where it starts, and it goes right into this cavity. This is a 1/4 inch A2 tool steel. And I experimented with it. I put a hole into here on an angle, at this angle. And watch what we're going to do. I'm going to put this piece on here with no clamp. We're just going to put a hole in there, and we're going to watch the operation as it puts the holes in there. So it's a stress-free cutting operation. Now we're going to start the spindle turning. Now we're going to have put the water on. All right, now we'll start the EDMing. As you see, the water's coming out of the center of the electrode. You can see the sparks shooting out from the cut. Now this is not clamped, and that's why you see a little shaking taking place. And this is real time. We're not making this go any faster. It's a 1/4 inch tool steel that we're cutting through here. It went through already. And you can see the water ejecting out from the back side of it. The holes that you see here, these 3 holes, I experimented a little bit putting holes into this piece. They're 1/32 of an inch, or 0.8 millimeter. We're going to be cutting this 1/4 inch tool steel again, so you can see what happens as it leaves the piece on the back side of it. So it gives you a little bit idea. And I want to stress something in the cutting of this here. Normally we would always clamp it down. We would never leave it loose. And I just wanted to show you that it's a stress-free cutting operation. What is because if the electrode hits the workpiece, there's a short circuit. There always has to be a gap between the electrode and the workpiece. So what's causing it to shake is the water pressure. So notice that there's water coming through the tip of that electrode. And when it gets in the hole, it's pushing out those EDM chips, and that causes pressure. So as you're watching, you'll see a little bit shaking taking place, but that's from the water pressure. We're going to start the small hole EDM again, and here you see it sparking from the opposite side. And we're going to watch it as it exits on the back side. As you see it shaking a little bit, remember it's not clamped. The water pressure is pushing a little bit against this piece of 1/4 inch tool steel. The electrode is spinning and water is coming out, removing the EDM chips. Broke through the other side. And there's the water now squirting out from the center of the electrode. If you want to learn more about it, you can go on our website, and this book is free. My son, who is a mechanical engineer, and I wrote this book, Complete EDM Handbook. And it's also used by colleges and trade schools. They purchase the book, and there's questions in the back. And also there's information about wire EDM and RAM EDM.
Located in the heart of the high-tech energy capital of the world, Reliable has the largest EDM job shop capabilities in North America, specializing nationwide in wire, RAM, and small hole EDM. Our commitment to our customers and our passion for technology has made us the EDM specialists.